A set is a collection of objects. We can name a set anything, although we'll stick with letters in this video. Shown here is the set A. The set A can be written using curly brackets, where everything inside the curly brackets is an element of A separated by commas. A set can also be written by using a property that the elements have in common. Either way is fine, although often for larger sets it is more convenient and less time consuming to write the set using a common property. In some sets there are too many elements to list anyway. This is read as A is a set of x where x is a positive integer less than 6. We use this symbol to say is an element of, and we use it like this, which can be read as 2 is an element of A. Similarly, we use this symbol to say is not an element of, i.e. 8 is not an element of A. Subsets are sets where all of the elements are contained in another set. For example, the set B of 1, 2 and 4 is a subset of the set A of 1, 2, 3, 4 and 5, as all of the elements of B are elements of A. Also, any set is a subset of itself, so A is a subset of A. The axiom of extension says that two sets are equal if and only if every element of A is an element of B and every element of B is an element of A. The if and only if means that both properties must hold for A to equal B. Some important consequences of this are the order when writing the elements of a set is irrelevant, and elements can only appear once in a set. There is exactly one set with no elements, called the empty set. An interesting property of the empty set is that it is a subset of every set. All of the sets we've looked at have been finite, meaning that there is a non-negative integer n, so that a set has n elements. N is the size or cardinality of the set. So if the set A looks like this, then the cardinality or size of A is 5. In a later video, we'll look at infinite sets, where it becomes much more challenging to measure the cardinality just by counting the elements. The union of two sets, A and B, is the set of all elements that are in A or B or both A and B. The intersection of the sets A and B is the set of elements that are in both A and B, in other words, the common elements of A and B.